I'd like to integrate sine the fifth x cosine squared x dx. And to get started, we are going to consider sine to the fifth x as being equivalent to sine to the fourth x times the sine of x. So notice I've rewritten this a bit. Sine to the fourth x is the same thing as sine squared x squared. And that's important because this is a Pythagorean identity. And so sine squared x is the same thing as 1 minus cosine squared x squared times the sine of x dx. And when I expand 1 minus cosine squared x, I'm left with 1 minus 2 cosine squared x plus cosine to the fourth x times the sine of x dx. Again, I can now distribute in cosine squared. This becomes the integral of cosine squared x, and I'll distribute in sine of x minus 2 cosine to the fourth x sine of x plus cosine to the sixth x sine of x dx. This is good because everything has the parts that I need. It's missing a negative sine x, but a positive sine x will help if I'll just think through what's happening. Cosine squared x, well, that must have come from cosine cubed x, and since the 3 was dropped and there's no number out front, there must have been a 1/3 here to start with, and since the sign's is positive instead of negative, this should be negative 1/3. Cosine to the fourth x, well, that must have come from cosine to the fifth x, and I'm going to drop the 5 when I take the derivative, so there must have been a 5 there in the first place that canceled out. And it'll be positive because the sine x is positive. Cosine to the sixth x, well, that must have come from cosine to the seventh x, and this will be minus 1/7 plus c. Again, really just relying on all of those sine and cosine properties that were initially introduced.